Okay, welcome to this video on solving trig equations using the general solutions. So I'm just going to run through what the general solutions are very quickly. So here are the graphs for sine and cos. So just looking at the graph for sine x, if we were to put in inverse sine of some value, let's just say it's here, and it hits the graph about there, so that would give you an output for inverse sine. This is what we'll call our calculator value, or CV. So it's what the calculator outputs, but there are other values, other solutions within the range 0 to 360. So if I keep going across, I actually hit the graph at another point, and that gives me another value. Now the way I find that value is by the symmetry of the curve. It's actually the same distance away from 180 as the first value was from 0. So the rule for sine is I can get the calculator value, and I can also do 180 minus the calculator value to give me two different solutions. But one important thing about all the trig curves is, or at least the sine curve, is that it repeats every 360 degrees. So with both of these, I can add or subtract multiples of 360, and I'll get even more solutions. That totally depends on whatever the range is in the question. Similar thing happens for cos. So say I put an inverse cos of a value, hits the curve. That's my calculator value. Because of the shift of the cos graph, the next solution is somewhere down here. And again, that is the same distance away now from 360 as the calculator is from 0. So to find that value, I'll do 360 minus the calculator value. So this is the rule for cos. I find the calculator value by doing inverse cos, and then I do 360 minus the calculator value. Again, the cos curve repeats every 360 degrees. So I can find more solutions that way. For tan, it's a bit simpler. If I do inverse tan of some value, it will hit the curve and give me the calculator value. Now, tan is a special type of curve that repeats itself every 180 degrees. So because of that repeating nature, the next solution is just going to be 180 degrees now plus the calculator value. And this is actually going to keep happening every 180 degrees, and also back here there's another solution down there. That's minus 180 plus the calculator value. So the rule for tan, find the calculator value and then add or subtract multiples of 180. So those are the three rules. You can make note of those. They're going to be on each of the questions that I go through, so I'll have a summary box for each of those. But I'm going to go through the three questions that you saw in a previous video using the cast diagram. So first one is this one, exercise 10e, question 2d. So you can see in the top right corner, there's the three rules for the general solutions, and I'm going to look at solving this equation. What you notice about this is it's sine of theta minus 10 and the range is theta. So the very first thing I need to do for this equation is change the range. The way you do that is you replace theta with now theta minus 10. And whatever we've done to theta, in this case is subtract 10, you're going to do the same to the other two things. So 360 minus 10 is 350. 0 minus 10 is minus 10. So this becomes your new range. This is very important when we're finding all of the solutions. Okay, so the first thing I'm going to do is find what the calculator value should be. So theta minus 10 is going to be inverse sine of this. Put that into your calculator, you'll get minus 60 degrees. So this is your calculator value. An easy way to deal with this now is draw up a little table. Your calculator value, and then whatever the rule is that you're applying to sine. And the rule for sine is this one. So I need to take the calculator value and I need to do 180 minus the calculator value. So the calculator value is minus 60. 180 minus that is 240. So I could look at those two solutions and say, are they in the range? Well, one of them is, 240 is, but minus 60 isn't. It's not between minus 10 and 350. But I can keep finding any other solutions. If I subtract 360 from both of those, I'm actually going to go outside the range. So I'm going to add 360 to both of them. If I add 360 to both, I get 300 and I get 600. And if I look back at the range, if I add any more 360s, I'm going to go outside of that range. Now, minus 60, as we said, is not between minus 10 and 350, and neither is 600. So those are two solutions that I'm not going to use. So finally, theta minus 10 could be 240, could be 300. But that's theta minus 10 is equal to those. I need to find the solution for theta. So I need to add 10 to both. So that's going to be 250 and 310. Okay, so that's that question. Very quickly look at the other two. So same exercise, question 4b. And this time it says solve in the range 0 to 180 for cos of 2x. Take care to see that we're not dealing with x, now we're dealing with 2x. So replacing x with 2x means I'd have to multiply by 2, so I need to multiply each of the endpoints by 2. 180 multiplied by 2 is 360, and 0 multiplied by 2 is 0. So this becomes my new range. Can find solutions for 2x by doing inverse cos. And if I do inverse cos, I get 143.13, something like that. So that's your calculator value. Again, draw up a little table, calculator value, and this time we're looking at cos, so it's this general solution now. So that's going to be 360 minus the calculator value this time. Calculator value is this. 360 minus the calculator value is this. So put that in your calculator. So again, looking at the range between 0 and 360, both of these are actually in that range, but I need to see if I can get any more. If I subtract 360 from either of these, I'll go outside the range. So let's add 360. If I add 360 to both, I get this, and I get this. Again, look, if I add any more 360s, it looks like I'm going to go outside the range, and these two are not in the range actually. So I conclude that 2x is either this or it's this. And to find x, I just need to divide by 2 for both of those. So I get 71.6 and 104.4 to one decimal place. Okay, final questions to look at. It's exercise 10F, and this is question 1D. This is a question of a slightly harder nature because we've got tan squared and we've got tan. So the way to deal with this is firstly recognize that this looks like a quadratic. So if you let a different letter, call it y, be tan theta, that means that y squared would be tan squared. That turns this entire equation into y squared minus 2y minus 10 equals 0. So that's a quadratic which you know how to solve. Unfortunately, we can't factorize that one, but we can use the quadratic formula, and I very quickly do that. Use the quadratic formula, we get something like this, and putting that into your calculator would just give you these as two solutions. Okay, so since y was equal to tan theta, I can now call tan theta either 4.32 or tan theta is minus 2.32. So now I've got two calculator values. So I'm going to draw up a little table. Calculator value 1, calculator value 2. And again, remember, we're looking at tan this time. So it's this general solution. So all I have to do is take the two calculator values, which are these, and add or subtract 180s to those. But I've just realized actually I haven't even found the calculator values yet. Those are not the calculator values. So to find the calculator values, I need to do inverse tan. If I do inverse tan on this side, I get about 77 degrees. Inverse tan on this side, I get minus 66.6 degrees. Okay, so actually one of those is in the range. Minus 66.6 is not, but I'm going to add and subtract 180s to those anyway, to both. If I subtract 180 from either one, I will go outside the range of 0 to 360, so I'm going to add 180s. Add 180s to both, I get 257 and 113. Add again, I get 437. 293, so that was adding another 180. Now if I look at all of these, I think there's some that are in the range. If I keep going, if I add 180s, I'm going to go outside the range. So I'm going to cross out the ones that are not between 0 and 360. So that's this, and that's this. And the other four are valid solutions because they are all between 0 and 360 degrees. So finally, all I have to do is list the relevant solutions and of course correct the three significant figures, and they are 77.0, 113, 257 and 293, all in degrees. So that's that question. I hope that makes sense. Okay.